If you travel 9,000 kilometers south of Paris, you'll find a tiny speck in the Indian Ocean called Réunion. Despite its location, Réunion is a fully integrated part of the French Republic. It's an indivisible part of the EU, giving this remote island direct access to the same massive infrastructure budgets as mainland France. But the land itself is a challenge. The interior is a vertical landscape of impassable volcanoes, which forces nearly every town, port, and road onto the island's narrow outer rim. When thousands of kilometers in isolation meet a coastline that won't allow another meter of road, engineers are forced to leave the land entirely and build in the open water of the Indian Ocean. The existing link between the capital and the port, the Route du Littoral, is trapped in a dangerous position. It sits at the base of crumbling cliffs that are constantly battered by cyclone-strength winds and massive ocean swells. In 2006, the cliff face finally gave way. A massive rockfall crushed the highway, killing 2 people, and forcing the government to find a way to get drivers away from the cliff face for good. The solution was to push the entire highway offshore. By moving the road into the deep water, they could bypass the threat of the falling rocks entirely. The blueprint called for 2 structures, a massive elevated bridge for deep water and a heavily armored rock dike closer to shore. As construction began, the complex bridge moved ahead on schedule, while the low-tech rock embankment brought the entire project to a standstill. The bridge required 48 massive concrete piers. Each one was shaped to minimize resistance to the tides and the violent swells common in this part of the Indian Ocean. The deck was built using hollow concrete box segments. These were cast in a factory on the island and then squeezed together by high-tension steel cables to form the bridge's spans. To assemble these pieces at sea, the project imported a specialist crane barge called Zorit. It was constructed in Poland and sailed across the world specifically for this project. Once in position, the barge plants 8 massive steel legs into the seabed. This provides a stable, stationary platform that allows the crane to lower foundations into the water with extreme precision. By 2017, this methodical precasting system was a success. The bridge was complete, stretching for 5.5 kilometers to become the longest viaduct in France. The viaduct worked because engineers used a highly controlled, tech-heavy approach that allowed them to build regardless of the ocean's volatility. The other half of the road was the dike. This was a more traditional approach, simply building an embankment up from the seabed to support the asphalt. To protect the dike from storms, it was covered in armor, layers of interlocking concrete blocks and boulders designed to sap the energy from incoming waves before they could hit the road. The problem with this design is the sheer volume of material it requires. The initial plans estimated that the project would need 7 million cubic meters of raw rock. To get that much stone, the developers planned to open 2 new quarries on the island. They assumed local blasting would be the cheapest and fastest way to supply the project. However, the island's ecosystem is highly protected. Local residents and environmental groups took the plan to court, arguing that the quarries would destroy the habitats of protected species and threaten the island's coral reefs. In 2018, a court ruled against the new quarries. Because the dike relied entirely on a massive supply of local rock that could no longer be extracted, the project ground to a halt. The team tried to find other sources. They began paying local farmers to clear volcanic boulders out of their fields and transport them to the construction site. They also considered importing rock from South Africa, but the cost of shipping bulk stone over 2,000 kilometers made it financially impossible. Then, a review found a major error in the original engineering. The dike didn't actually need 7 million cubic meters of rock, it needed 12 million. Compounding the disaster, a later inspection found that 800 of the concrete armor blocks had been installed incorrectly. Fixing that mistake alone cost 20 million euros. By 2019, the project had spent $2 billion on a road that was only 2/3 complete. The missing stretch became a massive monument to the logistical limits of building in such a remote place. In 2022, the government finally changed course. They abandoned the rock dike plan entirely and decided to finish the remaining stretch as an elevated bridge instead. A bridge running the entire length of the route was actually the original proposal. It was only scrapped in the early stages because it was deemed too expensive. But finishing it now is not an easy task. The specialist barge, Zerite, was already sailed back to Europe after the first bridge was finished, and won't be back on site for years. Modern engineering can solve the physical problems of the world's most violent oceans, but it still struggles against the logistical friction of being 9,000 kilometers from home.